Hello, welcome to my YouTube channel. Today I'm solving my puzzle, Magic Square Thermometers. The rules are that ordinary Sudoku rules apply, ordinary thermometer rules apply, and there's a hidden 3x3 magic square in the grid. I then go on to explain the rules, which I will do here. Ordinary Sudoku means that in every row, in every column, in every 3x3 box in the grid, the digits 1 through 9 appear once each. The magic square is somewhere in the grid. Thermal rules is that along thermometers, digits increase from the bulb to the tip. So this digit is higher than the bulb there, and this digit is higher than that one. This is a strictly increased rule, so this digit is higher than that one. This digit cannot be equal to that, it has to be higher than that. And then the magic square rule is that somewhere in this grid there is a magic square, which means that there are 9 cells in a square where the row, column, and diagonal all sum to the same number, and the digits do not repeat in that square. I've set up a blank screen here, a blank grid. I'm just going to map out a magic. Let's imagine this is the magic square. I'll mark it yellow. And so these three, those three, and those three all sum to the same thing. These three, and these three all sum to the same thing. Those of you who watch Cracking the Cryptic videos probably know that the digits 1 through 9 sum to 45, and you didn't hear that from me. 1/3 of 45 is 15, so each of these sums to 15, each of these sums to 15, and each of these sums to 15. The only digit that can be there with 4 pairs of digits summing to 15 is a 5. And these digits have to be the odds, 1, 3, 7, 9, because if these were odds, we'd have 2 odds and an even on that side, 2 odds and an even on every side. Well, 2 odds and an even add up to an even number, so the only way to make them all odd, all sides, all diagonals, and all columns and rows, is for the evens to be in the corners and for the odds to be in the orthogonally adjacent cells to the center 5. So that's what the basic layout is, and there are 8 different ways to arrange these numbers. You could have the 9 in one of 4 spots with the 1 across from it. That's 4 ways. You could have the 1 and 7, or the 3 here and the 7 there, and the 9 there. Or you could have the 7 here and the 3 there with the 9 there. And then each of those can be rotated. So nine here, 9 there, 9 there, 9 there. That's 4 different ways, plus each one has 2 mirror images, or 2 ways to flip the I shouldn't say flip, I should say reverse. Like if this is a 9, that's a 1. That could be a 3, 7, or as 3, 7. And every time you set up the grid, the 9 will be on one side with the 1 across from it. And I'll just do the 1 and 9. And then the 3 over here and the 7. Now, on this layout, the 8 can't go next to the 9 or the 7, so the 8 has to go by the 1 and 3. The 8 with 3 needs a 4 to make 15. The 8 with 1 needs 6 to make 15. And that 4 needs a 2 with the 9, and 2 and 6 and 7 add up to 15. Now you could flip the 8 and 6 and the 3 and 7 and the 4 and 2 and have a valid magic square. And then you could rotate the 1 here, there, and that's 3 times. Or that's 4 times in all where the 1 can be. And for each place the 1 can be, the 3 and 7 can be 2 different ways. So there's 8 different ways to set up a magic square with this array of digits. I'm going to leave this so we can refer back to it as we solve the puzzle. Okay, the grid is covered with thermometers, and there's no cell that's not on a thermometer. So we know that every 1 in the grid is on a thermometer bulb. And we know that every 9 in the grid is on a thermometer stem, or the tip. We also know that 8s can't go in bulbs and 2s can't go on tips. That is a little less useful, at least in breaking in. We know all the 1s are on 9s, and all the 1s are on bulbs, and all the 9s are on tips, and then we can look at rows and columns and boxes to see if there's only 1. For instance, there's only 1 in row 9. So we can put that 1 there, eliminate the 1s in the box, eliminate the 1 in the column, and then there's only 1 in this box, 1, 1, and then this is not a 1. Now this, there's no 1 here. The only 9 in row 2 is there. That eliminates this, which means the only 9 in box 5 is here. These are eliminated. The 9 here is eliminated, meaning that there's not a 9 here because there's a 9 in one of those two. These two 9s don't do much, but these two 9s eliminate that one. This becomes a 9. And now we have three discovered 9s and 2 discovered 1s. The magic square in the grid is going to be in between a 1 and a 9. The 5 is going to be in between a 1 and a 9, I should say. The center of the magic square. The center of the magic square cannot be on the perimeter. It needs to be surrounded by digits. The center of the magic square cannot be in any cell that does not have a 9 candidate on one side opposite a 1 candidate. So there's 9s and 1s there. There's 2 9s and a 1, but none of them are opposite the other. Therefore, that's not. This one is opposite 2 1s, and that's all. I'm sorry. Why am I don't want to color these yellow. I want to color them gray. This one is not between a 1 and a 9. This one might be. This one is not. No, this one might be. No, it can't be, because I didn't eliminate these 9s. Okay, this one can't be. That one can't be. Can't be. These can't be. These can't be. None of those can be the center of the magic square. Nor that. This 1 and a 9 puts a yellow square there. This 1 and a 9 puts a yellow square there. This 1 and 9, yellow square there. 9 and 1 puts a yellow square there. 1 and 9 puts a yellow square there. One and 9, yellow square there. 9 and 1, yellow. 9 and 1, yellow. 1, 9, yellow. 9, 1, yellow. I always have to check this part of the solve. For some reason, I find this really difficult. Okay, another thing that I forgot to mention is that we know that the magic square, wherever it is, has even numbers to its diagonal, and odd numbers are orthogonally adjacent. So no digit that is diagonal to an odd can be the center of the magic square, and that eliminates this one. Also eliminates anything diagonal to these and these, this and this. And at this point, we have 10 possible places for the magic square center, and because I've solved the puzzle a bunch of times, I know that that is the correct number. We can gray out everything else. Okay, now one by one. If that one is the magic square center, it's going to be 1, 9. This becomes a 2, 4 in some order. This is a 5, that's a 1. That was really stupid. 1 goes with 6 and 8. These 2, 4, 9 cannot repeat in the magic square, so the 2, 4, 9 go over here. But this 6 and this 8, whatever row they're in, or whatever column they're in, they're both greater than 2 and 4. So 2 and 4 cannot go in either of those cells. And I need 2, 4, 9 here if this is the center of the magic square. So it's not. It's great. The magic square cannot have a thermometer on its side. You can notice that on the side of the magic square, the center digit is either greater than the other two or less than the other two. And so a thermometer cannot lie along the side of a magic square. So anywhere there's a thermometer, the digit orthogonally adjacent to its center cannot be the magic square 5. This thermometer eliminates that. This thermometer eliminates that. This thermometer eliminates that, and we now are down to 5 possible cells where the magic square could be. The magic square center, that is, that's a 5. This would be a 1. Remember, these are 6 and 8. This has to be the 3 because it's small, smaller than 5. This is a 7 because it's greater than 5. This is a 2, 4. But remember I said that the 8 is always between the 1 and the 3. So this one is the 8. This one is the 2. And now there's no place for a 1 here because this has to be smaller than 2. It's a 1. That 1 puts a 1 here. And a 1 cannot go on those thermos. It has to go in a bulb. That's one of the hardest ones to see in the puzzle. I believe it's possible to do this puzzle without any kind of filling in of numbers. If that's a 5, this is a 1, this is a 9. 3, 7 pair here, and that's a problem because 7 can't go in either of these places. 7 there would put an 8, 9 there, but there's a 9. 7 there would put an 8 there, but that would sum to 15. This would sum to 17, and neither of those would allow you to add a third digit to sum to 15. That one was one of the more straightforward, I think. If this one is a 5, that's a 1. We have a 3, 7. 7 has to go up there, and the 3 down here. 8 here, 2 there, and 4 there. And now this pair of 1s eliminates that 1. And this digit can't be a 3, can't be a 1, so it can't be a 1 because the 1's in the box. So this is a 2. And now that 2 has to go in this box somewhere, but the 1 is already taken, so the 2 has to go in a bulb, so it goes there. And now I need a 2 down here on a thermometer that cannot have a 1 in its bulb. That was this one we were computing. This one is the 5. That's its 1. Now, this has to be a 6 or an 8, which is less than 5. And 6 and 8 is not less than 5, so this has to be a 2 or a 4, but that doesn't work because the 1 has to be next to 6 and 8 on its side of a magic square. This is not the magic square. That leaves one digit that is the magic square center, and that's, or one cell, I should say. This one here was should have been deleted. I'm going to get rid of my shading. I don't need it anymore. That 9 needs a 1 across from it. 1 needs a 6 and an 8. This is a 3, 7. This is a 2, 4. This has to be less than that, so it has to be the 3 and 4. And then just go across, adding to 10. 4 plus 6, 2 plus 8, 3 plus 7. Now, that one puts a 1 here. The one in this box has to be on a bulb. Well, my pencil mark showed me that that was the one. This is a 1, that's a 1. This is a 1, and that's a 1. And those are all my 1s. 9 1s. Okay, I can get rid of the 1 corner marks. And I've got 1 center mark there too. Okay. This 8 needs a 9, which clears that 9. Puts a 9 here by Sudoku with those two. These are not 9s. That 9 and that 9, see down there, that's a 9. These are not. That 9 clears these two. And now this one's a 9, and that's not a 9. This is, in this row, I've got a 1, 2, 4, 9. So I need a 2, 3, 5, 6, 7, 8. This one can't be the 8 because of that 9. I would need a 9 there if on that thermo. This number has to be less than 7, so it's not a 7 or 8. This one has to be less than 6, so it's not a 6, 7, or 8. There's now a 3 or a 5. There's no 3 in that box. I should say there's already a 3 in that box. This 2 has to go not there above a 4 on a thermo, so it has to go in one of those two. Can't go on that thermo without a 1 there, so it goes here. Then it goes down here somewhere, but it can't go in either of those spaces because they're the third cell on a thermometer. So the 2 goes there. Yeah, 2s are difficult. Anyway, this is at least a 3, so that can't be a 3. It's now a 5 or a 6. But it's not a 5 because there's one in the box, so it's the 6. No more 6s in a row. This cannot be a 3 because the 1 and 2 are already in the box, and one of them would have to be up there. This is not the 3. This is the 3. Let's see. This is a 5, 6, 7. We know that's not the 7, and that's not the 5. This is a 2, 3, 4, 8. But the 8 can only go on the, can never go on a bulb of a thermometer. So the 8 is there. This is not an 8. 5, 7 in the pair in the row makes that the 8, and this the 9. This is now the 9. I've got all my 9s. Get rid of these. Okay. This is a 5, 6, 7. Not the 7. This is a 5, 6. This is the 7. 7 in this box has to be on the tip of a thermometer because there's already an 8 and 9 in the box. The 7 doesn't have an 8 and a 9 to go above it on any thermo in that box. This always gets a little bit messy. 2, 3, 4, 5, 6. These are not, let's see, these are not the 2. These are not the 6. Six, 5, 4. Two, 3, not a 3. 2, 3, 7, 5, 6, 7. Okay. The only 6 in this column is there. This is a 5. No 5s here. This is a 5. What do I have here? This is a 3, 4, 8. This cannot be the 8, and it's not the 3. If it were the 8, then what's that digit? It is the 4. These are not the 4s. Last digit in the row is an 8. Last 3 digits in the row, 1, 2, 3, 4, 6, 7. Only 4 can be on a bulb less than 5. These are not the 4s. 6, 7 pair. The rest of this column is 2, 3, 6, 7. 2s are not there. 7s are not there. 6 is not there. This is not the 3 and it's not the 7. It is a 6. 3, 2, 7. Not a 3, not a 6. 6 in this box is there. 5 can't be below a 4, so it's there. This is a 2, not a 2, it's a 3 or 4. 3, 4 pair in the column makes that a 2. It's not a 3, 4. This is the 2. And my 2 should be resolved now. We've got a 2 there, 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 there. In this column, it has to be on the thermo with the 1. In this box, it has to be there. In this box, it's there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are my 2s. All right. This is 3, 4, 7 in the row. If that's a 7, that has to be an 8. Is that possible? Why do I think that's not? Well, this is not a 3, because that's a 3. That's not a 3. This is the 3 and the 4. There's a 3 in one of these two, but it can't be there, because there can't be a 2 there because there's a 2 there. So this is the 3. This is 2 digits left on a thermo, so they are 8 and 5. Now I need an 8 here. And these are 3 digits. 4, 5, 7. This can't be the 7, that can't be the 4. What do I have in the column? 4, 5, 8? This column has a 5, 7, 3, 8, and an 8 in the column. This is a 3. You can always tell when you have too many candidates. This is a 5 or 7. Can't have a 4 or a 5. This is the 8. 4 or 5 pair. 8, 8, 8, 8, 8. A 4, 6, because of that 7. This is not the 5. I say 4 or a 7. Huh. Okay, this is 3, 4, is it 6, 7? Not 7s, not 3s, not a 6. This cannot be a 4. That's a 5, 6, 7 pair, triple. I mean, this is a 3, 4. This is a 7 and a 6. 7 and a 4. 3 digits on a thermo are 3, 5, 6. We know the order. Then we type it in wrong. 3, 5, 6, 7, 6, 4, 3, 5, 7, 6, 4, 3, 5, 4, 7, and 5. And that's it. And my solution message is a Sudoku grid full of little thermometers with magic mushrooms where the magic square ended up. Hope you enjoyed it. Let me know. Take care.